let's recall the equation of a line. In particular, let's recall the equation of a line in slope-intercept form. Okay, let's take a look. You've all done this before, but it might be a little rusty. Let's recall that the slope-intercept equation of a line is y equals mx plus b, where m is the slope of the line, and b is the y-intercept. Okay? Example, let's find the equation of a line with slope 2/3 and y-intercept of -5. Let's go ahead and sketch it first. The y-intercept is -5, which means it intersects, the line intersects the y-axis at -5, and the slope, or the rise over run, is 2/3, which means, given any point on the line, we can get to another point by rising 2 and running 3. So there's that line that is described in our example. And of course, the equation, we can just copy it down, is y is equal to m x plus b, or -5. Okay. So there's a little bit of review. Now, we're going to do a couple problems here. Notice we're given a cosine, so we need to know a little bit of trigonometry here. It says, find the equation of a line passing through the origin. So we know what the y-intercept is. We'll write that down. The origin is right here. So the line goes through the origin, or at 0, is the y-intercept. So let's read this again. Find the equation of a line passing through the origin so that the cosine of the angle between the line in quadrant 1 and the positive x-axis is 1/2. Now let's go ahead and sketch this. Keep in mind my drawing may not be to scale, okay? But it says the cosine, okay, of the angle between the line in quadrant 1, so we know the line has to be in quadrant 1, and the x-axis is 1/2. So let me go ahead and just draw a line. I know it goes through the origin. Okay, so here's an angle. Call that theta. It says the cosine of that angle must be 1/2. So let's just draw this imaginary little triangle here. Cosine, remember, if this is theta, cosine is adjacent over hypotenuse, must be 1/2. All right. So what do we need for the equation of a line? I've got the y-intercept with 0. I just need the slope. In order to get the slope, I need to figure out what the rise is. Well, if this is theta, if this is 1 and this is 2, that's our 1, 2, square root 3 triangle. Okay. So theta must equal pi thirds. Remember, cosine of pi thirds is 1/2. Okay, so that's how we figured out this y value here. So the slope of this line must be the y, the rise, over the run. So I know the equation is y is equal to m x plus b, and of course we don't need the 0. Just y equal square root 3x. A little tricky. Let's do one more. Same problem, just a couple different numbers, a couple different words. Find the equation of a line passing through the origin so that the sine of the angle between the line in quadrant 2 and the positive x-axis is square root 2/2. Here's quadrant 2, so I know my line goes through the origin, so again b is 0, and all I have to do is find the slope. So the angle between the positive x-axis and the line, there's theta. Okay, we don't know what theta is yet, but we do know that the sine is square root 2/2. Now, remember, that's the same thing as 1 over square root 2. Okay? We should get in the habit of recognizing that 1 over root 2 is the same thing as square root 2 over 2 and vice versa. So I know the sine, which is opposite over hypotenuse, is 1 over square root 2. Okay? Therefore, this side here must also be 1. Okay? But it's in the negative direction. So it's negative 1. So what I've done is I've created this little right triangle, and I'm just filling in the sides of this little right triangle. So I know that the sine of this angle is 1 over root 2. Therefore, this little angle must be 45 degrees. So this also has to be 1. But since it's in the negative direction, it's negative 1. So now I've got the y-intercept. The slope now is easy because it's the rise over the run. So the equation is y equals mx plus b, or just y is equal to minus x. And there is the equation of the line. Okay. So you notice we had to know a few things. We had to know what sine meant, and we had to know what our 45-degree right triangle looked like. And we also had to know the equation of a line. So again, you can always review these lectures as many times as you wish. That's the beauty of this course. And certainly come by Polia, and we can help you do your homework problems there as well.